Hey, hi everyone. This is a new problem that we have. It is typically called rotate uh, a list by a given offset. So in this case, it is actually a right rotate, but there could be variants of it as like left rotate, etc. So I will give an example of what rotate actually means. So let's say we have this array here, right? And this is the index 0, 1, 2, 3, 4. We have this array of elements 10, 20, 30, 40, and 50, right? So when we rotate it once, basically what happens is from the fourth index, it will become at the zeroth index, right? 50 comes up front and the rest of the values gets pushed. In the second rotation, basically what happens is now 40, which was the last element, comes up in front, and then it's 40, 50, 10, 20, 30. In the By the third rotation, you would see the same thing happen, right? So after three rotations, you would end up having something like this, list like this: 30, 40, 50, 10, 20, right? So this is actually the right rotation, but there could be also left rotation. This problem that we are looking at is right rotation. So here the question is, we want to output the final um, rotated list or array. So that's the problem statement, right? Now, now there is actually a huge clue. So when we look at the rotations and all that, it might seem like something complex is happening, but there's remember that this rotation operations is all happening in a sequential manner. So there's clearly some kind of a pattern that we can deduce from here. So when we say three rotations, right? So we did three rotations here, and this was our initial starting array. I'm going to erase maybe all these guys so that we can focus on the final result. Okay, so after the third rotation, we got this. Now, if you look at it, it is basically same as from the end going to the third element, right? Going to the third element and picking up all the three elements from there, right? Moving it front, and then whatever is remaining in the front side, you are just appending it till this point, right? So it is same as, let's say, concatenating this list which you have found from the back side by moving three elements with the initial other elements that you have from the front side, right? So that will kind of give you the same effect as rotating by right. Now, so we can write two solutions to it. One, I would say, is a clearly Pythonic way of solving it, which would be using the slice operation. But since this is data structures question, we'll try to not use things like slice and try to see how we can use write code when that's not possible, right? So let's write def rotate list. We get a list here, and we'll also handle some edge conditions, right? Let's say if the len of list is you know um, lesser than 1, then we can probably return the list itself here, saying that it might be an empty list, right? um, the other thing is, okay, we need to also get the offset. The offset is a k, right? The number of rotations that we need to make. So this rotations, one thing that people interviewers might ask to throw candidates off is that they can say that I can say that there could be 100 rotations made on this list, right? So rotating 100 times means what? So in this case, it is going to be same as effectively doing 100 percentage what is the length of this array. So length of this array is 5. What would you get? It is basically going to be 0. right? Remainder is going to be 0. So k, it is effectively same as doing k is equal to 0, because you, when you have finished rotating, you're basically going to arrive at the same point, right? So we need to handle that normalization. So that normalization can be done like this: k is equal to k percentage len of list, right? So that takes care of normalization. Now coming to the final result, so we'll put maybe a result array here, right? And then we'll iterate. So we will iterate first to get this right hand side value, right? From the back side basically. So that's going to be idx in range. So here we are going to actually find from the length of the array, which is 5, minus k, right? K here is 3, so we will arrive at 2 by that thing. So it's basically len of list minus k to len of list, right? I'll just write down what this entails. This is going to index from 2 to 5, right? That's what this is going to be doing. So we will just append rest dot append basically the list of idx. So this will get us now all the values from 2 to 5, index 2 to 5. Now what is missing obviously is appending values from 0 and 1, right? So how do we get that? We get that by appending from, by iterating from 0 to gain len of list minus k, right? So this is going to iterate from, I'm going to write the comment here, 0 to 2 in this case. Remember in Python, when we say we are iterating to 2, effectively it stops at 1, right? So then we are going to do rest dot append of list of idx, and again return res, right? Now this is basically a solution that we have implemented without using the famous Python operation called slice. So we can effectively use slice here to solve this problem as well. For doing that, basically what will happen is whatever is the code here, this entire portion we would still need. I'll just copy it. Yeah, so this code we will still need, and what we would need other than this is going to be a simple slice operation. So I can do return list of, right? So what we are basically saying is we need till from minus from minus k till the end, right? That is what we are doing. We are taking from 2 to 5, right here. So that could be represented in Python very simply like this, right? And what is the other thing that we are doing? That we are doing from 0, we are going till minus k, right? So that could be represented like this. So this is obviously a simple Pythonic solution. This is the preferred way to write code in Python and making it much more clearer. But this is actually more low level code. But you can see that the time complexity effectively for both is kind of like off, and this is a much more cleaner way to write the code. That's pretty much it. And see what what will be confusing for people might be this, the difference between this being positive and this being negative. So when you are putting a positive value here, let's say if this is positive and let's say k was 2, that means we are going from 2 to 5, right? But when it becomes negative, that means we are essentially doing 5 minus 2, sorry, 5, whatever is the case value, and then from there we are going till the end of the value. So that's a meaning of minus k. So it's a nice powerful idea, but sometimes when you're writing the code, we might have to end up writing it in this way. Let's say if people are if the question and explaining things like complexity for this operation might be a little bit hard, so it's better in that case to kind of write this solution. And anyhow, like I said, it's all often, and the key part is basically understanding that the way to normalize stuff is by doing this modulus operation, right? So when you do this modulus operation, you are going to effectively, let's say if it's, we are calling it 103 rotations, then that is effectively same as doing 3 rotations, right? So that is a key distinction to make, and from that part of understanding that it's 3 rotations, it is also about looking at the array and figuring out that the rotation effectively means splitting the array into 2 chunks and taking one chunk and then appending that chunk to another part of the array, right? So that's pretty much for this problem. See you with another problem.